Today's video is on section 4.3, Riemann Sums and Definite Integrals. Your homework tonight is 4.3, 15 through 43 odd, 47 through 50 all. And so technically we've already been doing the Riemann sums where you add up the area underneath the curve by using geometric shapes. So now let's put some formality into what we have been doing. And then we'll continue on from there. So this is actually what we've been doing in the FRQs. The definite integral as the area of a region. So if f, my function, is continuous and it is not negative, which means it's above the x-axis, on the closed interval from a to b, then the area of the region bounded or closed off by what? By the graph of f, that's above the x-axis, the x-axis itself, and then the vertical lines x equals a and x equals b, which are formed from the closed interval. And this is given by this antiderivative or this integral. So an integral is actually area. And this is what we've been noticing in our FRQs. And so A is a smaller value, B is the larger value, because again, this is an interval notation. So the smaller value goes here, or the value on the left on the x-axis. B is on the right, or the greater value on the x-axis. So that's what it's bounded by. Those are my two vertical lines. Here is my function, which is above the x-axis, and then the x-axis. That's the area. So now let's do some properties. Properties of definite integrals. There's about 5 of them. So here's the first property. That if I'm going to find the area, or take the definite integral, and the closed interval is of itself from a to a for this function, f of x times d of x, that equals to 0, which makes sense because from a to a is 0. 0 times anything is 0. 2. Again, my closed interval, we're going to call it from a to b. If they give you this this definite integral from a to b for this function of dx, please note that they have these out of order. So what you do to switch their order is you just do the opposite. To do the opposite, you factor out a negative. So you have a negative and you're able to switch these back properly. Now you can continue taking the area and make sure that you have the -1 out front. You multiply the area by that. The third property of a definite integral. So let's say it's on the closed interval from a to c. They're just letters a, b, a, c, doesn't matter. Just ac suits my purpose for this demonstration. From a to c for this function, then, for example, if it's like a 0 and a 3, so the b, I'm going to have that be in the middle, maybe from 0 to 2, plus from 2 to 3. And both of these definite integrals have to be times dx. Another property, property number 4. So let's say I have some constant k, like a 2, square root of 2, 1/2, 1/8. So 1/8 times the function, I can go ahead and I can factor out that 1/8, that constant number. Again, this constant has no x in it. Then I can continue taking the area and at the end take the area and multiply it by that. The fifth property. So now what if I have two functions in one definite integral and I'm going to add these two or subtract these two? what I can do is I can separate them and give each one their own integral. And so if there's addition here, you have to have addition here. If it's subtraction here, you have to have subtraction here. But each one is times dx. So before I get started, one more time, I want to make sure that we make note that if my interval is from a to b, that b is the larger value, goes on top, a is the smaller. You need to make sure you verify that. Or in other words, on the x-axis, this is the far left, this is the far right. The second thing I want to make mention of is here is your curve. And for the definite integral, it's supposed to be non-negative, in other words, above the x-axis. So this area here is positive. If you do any areas, and you will today in your homework, these areas are negative. So when you add up those three areas, this is a positive number, two negative numbers. Add up all three of those. Unless, like on one of our FRQs over the last 2 days, we had the absolute value of a velocity question, and we had one where it was above and below the x-axis. When it's the absolute value, we know signs don't matter, everything is positive. Then all of the areas would be positive. You had one of these on the FRQ, you will not have an absolute value in this homework assignment. All of the homework problems will be this is positive area, this is negative area. So now let's just do a whole bunch of problems. So here's the directions. Set up the definite integral only. So they're going to give you a function. This is actually number 14. Let's not look at that because I already did it. They gave you the picture, and then they're going to show you the shading. This is the area, and they want you to set up the definite integral. So an integral is the area, and it goes from what? From 0 to 2. So 2 is the upper bound, 0 is the lower bound, and then you write the function here times dx. Done. Let's try another one. Number 16. So it's a quadratic, the parabola, x squared. And so they're going to have a picture. Again, I've given it to you already. Here's a piece of it. You know, it goes 0, 0, 1, 1, and then 2, 4. And so they give you a small piece, and they have this shading. And they want you to write the definite integral for this so that you could go and find the area. Even though in 16 you're not going to find the area, you're just setting up the problem. So the area is an integration, and it's going to be from 2 to 0. And the function is x squared times dx. Let's do one more. Number 22. Please note this is as f of y. This tells you that the variable on the other side of the equal sign is y. That's my independent variable. So there's the sketch of the graph. Here's the area. So that's going to be integration. It's going to be from 4 to 0. We're going to have the function, because it's the area underneath that function, times dy with respect to y. That's my variable. That's my independent variable. So those were setup problems only. Here's the next set of directions for some of your homework. It says sketch the region described by the definite integral. Then use geometric formulas to evaluate the integral, because right now we don't know how to do the integral. So we're going to use geometry in order to do the area, which is what an integral is. So here's a problem. So this is going to be equal to area. This is properly written. This is a larger value. This is a smaller value. These are the values on my x-axis. And here's my function. So I can write it like this. Y equals 4. That's my function. So it's going to be, this integral is the area underneath the curve. So let's go draw that picture. So I'm going to draw the x-axis, make sure I go from -2 to 3. draw in that function y equals 4. I sketch that out. And remember, I will get it back out so I can show it to you again. The definite integral is area. It is bounded or fenced in by the graph of f, the x-axis, and the two vertical lines x equals a and x equals b. So I have to find all of those. So there is my x-axis, there is my vertical line x equals -2, x equals 3, and then my function happens to be a horizontal line y equals 4. I need to find the area of this. Now in the direction says use geometric formulas to evaluate that integral. Well, that's just a rectangle, so the area of a rectangle is length times width, and so the length and the width are 5 by 4, which is 20. Let's try another one. So again, I like double checking to make sure that this is greater than this. It is. My upper bound is 4, my lower bound is -4. Here is my function times dx. So some of you might have forgotten what this function is. So I'm going to go through it. The parent function is your absolute value of x. Remember, it looks like this. It's your v. So that takes care of this piece. What's that negative? The negative means reflected over the x-axis, means it's upside down. And then a vertical shift up 4 units. That's on the outside of the function. Outside of the function is vertical and it's intuitive. It's what you think. Vertical shift up 4 units. And it is, I'm going to take the area between -4 and 4 on the x-axis. So I need to sketch all those pieces together. So from -4 to 4, there is my absolute value function. Over 1, down 1, over 1, down 1, over 1, down 1, over 1, down 1. It connects right here. How did I find that? By all the steps I just went through. And so this is the area underneath this curve, underneath that function, between -4 and 4. So here I don't have any vertical lines because they connect here. So it's just the function and the x-axis that traps this. And so I have to find that area. So then I ask myself, what shape is that? It's a triangle. So that is the area equals 1/2 base times height. My base is 8, and my height is always perpendicular to my base. I'm going to go straight up. That has a height of 4. So half of 32 is 16. My last problem. Again, I'm going to find the area underneath this curve or this function. This is properly written from 2 to -2, except this is a function that might not be so easy to remember. Let's see if I can jog your memory. Remember the equation of a circle centered at 0, 0 is x squared plus y squared equals r squared, r being the radius. So if I take that equation and start rewriting it, so I'm going to subtract x squared from both sides. Then to get to my y, a y equals function, I just take the square root. So this, whoops, it's out of the screen. This is looking like this, because this is a y equals. This is y equals the square root of 4 minus x squared. And remember, when you take the square root of both sides, there's a positive and a negative. So the positive is the top half of the circle, and the negative is the bottom half of the circle. Because they gave it to us like this, it is the top half. And it's from -2 to 2, but my radius, r squared, so what makes a squared equal to 4? A 2. So my radius is 2. I am now ready to draw this. So there is the top half of my circle, centered at 0, 0, with a radius of 2, and it connects at the lower bound and the upper bound, -2 to 2. Now what am I supposed to do? I'm supposed to find the area underneath the curve, because that's what the integral is. The integral, the definite integral, is the area underneath this curve from -2 to 2. Well, I don't have a formula for half, but if I take a circle, which is pi r squared times 1/2, that will be the top half. All I need for that equation is the radius, which happens to be 2, So 1/2 pi times 2 squared is 2 pi. Thank you.